Hello, Miss Sanders mathematicians. It's me coming to you with another video. We are now on mathematics gymnastics. We've already done the warm-up. We've done the getting started. Now we're going to start on the activity 2.1. As always, I have a multiplication chart handy. I have my scratch paper for my grid paper where I'm going to use the front or the back. And I have all my pens, color pencils, things that I need to highlight, make my life easier. Please feel free to get color pencils, whatever you need to color code and make your life easier when doing math, because math is hard, especially when it's in black and white. Anyway, so we are going to consider the four expressions plotted in the previous activity. How can you prove that you're correct? So if you remember, we did our getting started. That was our previous activity. We plotted them, so we're going to use those four expressions to do this video here. So Graham, before we answer that question, Graham, he has an example, and he's saying that I can use an example by evaluating all four expressions at the same time, at the same value of x, and plot the values, which is what we did in the very first one. But Megan, she says the expressions look similar. I can factor out the coefficient of each expression. So the coefficient is the one thing that they have in common, that you can take out, the number that you can take out. And then the x plus 1 is the one thing that they have in common. So I want us to look at number 1. Use Graham's strategy with the different positive value for x. So Graham used x equals 4. Let's just use the one we did here in the beginning, so we won't have to do double work. So we use 3. So that's what we're going to do to accurately plot the four expressions. Well, we know how to plot them because we did it in the first one. So let's just use this one and not make life hard. So we knew that here was our 0. We know that x plus 1 started here. 2x plus 2 is here. 3x plus 3 is here. And 4x plus 4 is here. All right, so we plotted the four expressions. We already did what Graham did. Graham did 4, so he plugged in 4 for each one. We plugged in 3 for each one, and we got our answers. So now we're going to use Graham's strategy with a negative value for x to accurately plot the four expressions. And then how is your number line different in question 1? So now we need a negative value. So I would suggest let's plot -2. X equals -2. And so I want you to pause the video at this point. I want you to use your scratch paper, and I want you to go through using -2 for x. I want you to go through and answer x plus 1. So instead of x, you're going to do -2 plus 1. You're going to substitute the -2 for x, and you're going to solve those. And when you come back, I want to see what numbers you got for each one of these. So when I wrote the wrong number, so make sure you write the right number. And then 4x plus 4. So I want you to pause the video at this point. I want you to work those out and see what you get. Hopefully you have paused, you have done what you're supposed to do, you have worked it out, because the first step is you have to try and have a productive struggle first. So if I work them out, this is what it looks like when I rewrite my expression, substituting my x values for -2, because we want to use a negative this time. -2 and 1 is -1. 2 times -2 is -4, because the negative and a positive makes a negative, or negative times a positive make a negative. I'm going to add that, and I get -2. -2 times 3, positive 3 is -6, and I'm going to add 2, and I'm going to get -4. And then the last one, 4 times -2 is -8, and I'm going to add 2, and I'm going to get -6. All right, so So now I'm going to plot these on the number line from greatest to least. This time, all my answer values are less than 0. These were greater than 0, but now these are less than 0. So I have to plot them going this way. And the one that I have to plot first is the one that equals -1, which is x plus 1. I'll just put my value on top. And then 2x plus 2, which was -2. 3x plus 3, which is -3. 4x plus 4, which was 6. And this one was -4. That's why we use a pencil so we can erase. So now I want you to answer this question. How is your number line different from the number line in question 1? So find some space and write about that real quick. You can write about it in this space here, or in the like space underneath. Just a sentence. How is it different from the number line in number question 1? I look forward to your answers. So I'm going to change the page real quick. So it says, often writing an expression in different form reveals the structure of the expression. Megan saw that each expression could be rewritten as a product of two factors. So I have Megan's right here next to me. And what Megan did instead of solving it is she noticed that they all had x plus 1 in common. So she said that, well, these are 2's. So if I take the 2 and pull it out, I can just multiply 2 times x and 2 times 1, which will give me 2x plus 2, because 2 times x is 2x's, and then 2 times 1 is 2. And then this time she pulled out the 3. And then, so if she were going to resolve it, she would do 3 times x, which is 3x, and then 3 times 1, which is 3. So then this one, she pulled out the 4. So it says, what are the two factors in each of Megan's expressions? And so those factors are always x plus 1 and then the coefficient. So this her 2 one was well, let's start with x plus 1. The coefficient here was 1. The coefficient in the next one, which is 2x plus 2, was 2. We just pulled the 2 out. And the same thing with the 3x plus 3, we pull the 3 out. So, sorry, I think ahead and then I write something different. So then I want you to write what the coefficient was for the 4. And I look forward to seeing what you have. But all the expressions can be written as something, the number or the coefficient times x plus 1. So now we're going to use Megan's work to accurately plot the 4 expressions on the number line. And we've already done that because we did it on the last one, but this is just another way to see it. So we know that all of these are positive, and then we would know that 1, 2, 3, and 4. 1, 2, 3, and then whatever you come up with that one. And so that's how we would plot it on the number line. It should be x plus 1, 2x plus 1, 3x plus 1, because we're going to multiply everything times 3, and then with the one that you came up with here, so you can see it. So now Megan's noticed that the expressions, so make sure you write this one, and write this one, and write this one. Megan noticed that the expressions formed a sequence. Write and plot the next 2 terms in the sequence. So if we have this number line, and we know that this is our number line, and this is what you should have wrote for your next one here, then she wants to know what would be the next 2 numbers in the sequence. I want you to figure that out. You got it, and we'll talk about it. And then what property did Megan use when she factored these out? I'm not sure if you're familiar with this. It was taught in 6th grade, but if you don't remember and you guessed it, or you do remember and you guessed it right, hopefully you remember the distributive property. The distributive property is when you take the number and you multiply it times everything on the inside. So 4 times 4x plus 1 is really multiply 4 times x, which is 4x, multiply 4 times 1, which is 4. And then you use the symbol in the middle to do that. And now we have the original 4x plus 1. So that's called the distributive property. I like to remember it by saying hippity hoppity distributive property, because I have to hippity hoppity to everything inside the parentheses to make sure that I multiply all those things. So hippity hoppity, gotta hip along, multiply everything inside. So now you have just discovered the distributive property through Megan's example. Way to go, Megan. See you in the next video.